So good morning, everyone. Myself is Dr. Ajit Kumar, and I'm faculty in the Department of HE. So we will start our sixth lecture. That will continue our program status for registers of over 8051 that we had started in the last class. So in the last class, I said something about the RAM organization, and I discussed about that how we have four register bank in this RAM. So just I'll show you once again that four. This was the something that we had started. Let's say this was. So let's say this is our RAM chip. This is our RAM chip, which is 128 byte in the capacity. And we discussed that we have total four register bank here. So let's say this is register bank 0, this is register bank 1, this is register bank 2, and let's say this is register bank 3. And I told you that in each register bank we can store 8 bit of data, that is 1 byte of data can be stored. So here we have 1 byte of data, here also 1 byte of data. Okay, so like this we have in each case we can store 8 1 byte of data. Okay, 1 byte of data. So this was the register bank 0. This is register bank 1. This is register bank 2. This is register bank 3. Now, what happens here? This is the starting address 00H. Okay, it goes up to 07H to the register bank 0. This goes up to 07H to register bank 0. Then the starting address for register bank 1 is 08H. Okay, so 8 plus 8 16, but it will not go to 16, it will go up to 15. So 15 is 0H. Okay, and so on. Now this one, this second register bank, okay, this that is register bank 1. Register bank 1 is also used for stack of person, stack of person. Okay, that is this register bank is also used as stack memory, stack memory. So what happens when we switch on our microcontroller 8051? Okay, when we switch our 8051 microcontroller, then by default, okay, by default, this SP register, stack pointer register points to 07. Okay, we know that this stack pointer register is used to stack to the top location of our stack memory, and similarly, PC register will point to 000H. These are the default values which are loaded into SP register and PC register. Okay. Also, register bank 0 uh, is uh, is the by default is the default register bank which is you can say operated here. So by default, this one, okay, this is the first thing. Second, PC, and this is the third condition. That is, these three occurs when we switch on the microcontroller. Okay. Now, what is happening is, first of all, in PSW register, okay, in PSW register, we have seen, okay, there was this RS1 and RS0 bits. Okay, So these two bits actually is used, actually I think this is D3 and D4 of our PSW register. So they are encoded here. They are encoded here to choose the register bank. For example, if this is 0, then register bank 0 is selected. Similarly, if it is 0, 1, okay, then register bank 1 is selected. So when is 1, 0, then register bank 2 is selected. And finally, if they are coded as 1, 1, then register bank 3 is selected. Okay, so I'll write here select. Or you can say here select. Okay. So in this case, what is happening? mm, for each, okay, now if you recall, we have total R0, R1, R2, R3, R4, R5, R6, R7. They are the registers which we know in 8051 microcontroller. Registers of 8051. Now we know this. There are total 8 locations in each register bank. So what is happening? Mm, Here, so 1, 2, so 1, 2, 3, 4, 5, 6, 8. So this is the first location 0, 0, then 0, 1, then 0, 2, 0, 0, 4, 0, 5, 0, 6, 0, 7. They are not properly aligned, but they are actually like this 0, 0, 0, 1, 0, 2, and so on. This last 0, 7 is this location. Now, what we have done is we have also assigned these addresses to these registers R0, R1, R2. Okay. So, for example, suppose I want to move something in this location. Let's say I want to store 0 codage in this memory location. So suppose that in this memory location 0, 4 I want to store. So you know which instruction I'm going to write. I will write like this: move. Here we are writing destination and then we are writing source. So what is source is constant number 04, and what is destination is this address 00H. Because you know that move instruction is having two operands. One is destination and one is called source. So the source will get transferred to the destination. Here source is 04, which will be stored in this location. Okay. Now this is one way. This is the one way of doing this one. The same thing I can write like this also. I can write like this: move, okay, R naught, comma, has 04H. Why? Because this R naught is having, okay, address, having address 00H. Fine. Similarly, this next address is the next address is 01. So this 01 is assigned as R1. Okay, that is address 01H is assigned for the R1, then 02 for R2, and so on. Okay, so I can show you something like this. Suppose that you have this register bank 0, so 1, 2, 3, 4, 5, 6, 7. So this is the address 00H, which is assigned to address R0. Similarly, 01H is assigned to R1, then 02H is assigned to R2, like this. This 07H is assigned to R7. Okay. So what I said is, what I mean, this is applicable for all these registers R0 to R7. Okay. So if you want to move something into the address 007H, so either you can write something like this: move 00H, comma, has, let's say 04H, or you can write move, now this, sorry, which address 07H. So I was saying about this address 07H. So suppose that I want to store something in this address 07H. What is the data? This is the data I want to store. So I'll write something like this. Okay, this is destination, this is source. So source will get moved into this address, okay, 07. The same thing is possible if I write something like this, move R7, comma, has 04H. Both have same meaning, okay. So like now thing is, the same thing is applicable for the register bank one also, okay. I show you, see. So let's say up to here register bank 0 was there. So this 00 was assigned to R naught. Okay. Now the let's say this is the registered bank 1. So what is the starting address? Is 08H. The 08H address is also assigned to R naught. Okay. Now similarly, this address 01H is assigned to register R1. Similarly, this address 09H is also addressed to assigned to register R1. Similarly, the next address in register bank 02H is assigned to R2. Similarly, here the next address is 0AH, which is assigned to R2. Okay, uh, and this is again applicable to register bank 2 also. So in the register bank 2, it will go up to 0FH. This register bank 1 is last address is 0FH, and the starting address of register bank 1, that is 17, that is 10H. Okay, this will be assigned to again R naught register. Then we have next address 18 in decimal. 18 in decimal is 1 2. Sorry, this is 1 1. No. Actually, it is 16 in the decimal. So in hexadecimal, it is 16 divided by 16. 16. So it is 1 0. So 1 0 was correct. Then 1 1 H. Okay, that is 17. Okay, 1 plus 11H. Similarly, like this 11H is assigned to R1. Then we have 12H is assigned to R2. So this is again applicable for the next register bank R3. So whatever is the starting address, no, that is assigned to R0 and so on. Now the question is, suppose I have written here like this: move R0, comma as 04H. So we know that this 04 will be loaded in the register R0, okay, after execution of this instruction. Now the question is, this R0 is pointing, 00, okay, this R0 is also pointing 08, this R0 is also pointing to R0, 10H. Then the question is, in which address, okay, which address this 04 will be will be saved or moved in, okay, in which address, okay, which address means 00H or 10H or 08H. And okay, the push, so this is one thing. Okay, similarly, if I would have written here move R1 comma as, let's say, 05H. So I know that this R1 will be stored with this constant value 05H. Okay, but the question is again, which address? Is it going to be, this R1 is here also. Okay, R1 is here also, R1 is here also. So whether this will be assigned to address 01H, okay, 01H or 09H or 11H. This is the question. Here also this was the question. Okay, so this is actually just now, if you remember, I was telling that register banks are selected using D3, D4 bit of your PSW register. Okay. So that is actually done. by selecting. Okay, first of all, first of all, you have to select okay, okay, the registered bank by selecting register bank. Now recall this was our PSW register. Okay, so we have seen the PS register in which this RS1, RS0, okay, is the 3 and the 4 bits, and these bits I'm not talking about. Okay, these bits I'm not talking about. Also, if you see this last bit, that is T0, okay, whatever it was. So we also designate them something like this. This one I'll designate by PSW dot 0. The next bit will be designated by PSW dot 1. Similarly, this D3 will be designated by PSW dot 3. This will be designated by PSW dot 4. Okay. Now, suppose that I want to select, okay, suppose I want to select, I want to select register bank, let's say 2. Okay, so in that case, okay, this bit, okay, in that case, this bit should be 1 and this bit should be 0. Okay, this bit should be 1, this bit should be 0. Fine. Now, to set this bit RS1, that is PSW.4, we have instruction called set. Set, what we are setting of one bit. So I'll write here set B. B means bit, set bit. Which bit I'm going to set? PSW.4. So by using this instruction, the PSW.4 will become 1. Okay, and similarly, I want that this RSW0 or D3 bit or PSW.3 should be 0. So I write here CLR. Even if you don't write CLR, by default it will be 0 only. So I write here CLR PSW.3. So by using this instruction, your PSW.3 will become 0. Now, by writing this two instruction, the register bank 2 has been selected. Okay, now onwards. Now, after this instruction, suppose that we have written something like this. Let's say I have written instruction move, or let's say R1, or you can say R0, comma, R04H. Okay, so what is this instruction? We know R0 register will be stored with this value 04H. Okay, that is fine. Now, since we have selected the register bank 1, okay, so this is register bank 0, this is register bank 1, okay, then we have register bank 2 and 3 also. Now, since we have selected this register bank, okay, the selection of register bank 1 has been not done, actually 2. So, register bank 2. Okay, so this register bank 2. So, we have selected this register bank. So, register bank 2 has been selected. So this R0 will be pointing to the first address of register bank 2. So here it was 15 and 16, so it is 10 address. 10. Okay, so meaning of this instruction is the address 10H will now contain 04H value, which is a constant value. So after executing that instruction, this 04H will be stored here in address 10H. Okay, this is how we select the register bank and we will move the data. Okay, using registers. Okay, this is how we are doing it. Fine. Similarly, suppose that I want to select the register bank 3. Okay, so suppose that I want to select register bank C. So in that case, this PSW. So what I need is to select the register bank 2, I node sorry, RS1 and RS0 should be 1 1. Okay, both bits should be set to 1. That is, so I'll write here set B, set B, sorry, set B PSW, PSW dot 4, and then I'll write set B PSW dot C. So using this two instruction, this two bit will be set to 1, and then our register bank T has been selected. Okay, has been selected. Now suppose that you are writing something like this. Move, let's say R7, comma, any constant value, 0 for h. Okay, so this 0 for h will be stored in the address function. Okay, in the starting. Okay, so this 0 4 will be stored in the starting, no, not starting, and address of register bank 3. Okay, so in the register bank 3, register bank 0, 1, this is register bank 0, 1, 2, 3. So this 0, 0 was the starting address, then 0, 7, then 0, 8, then 0, F, then 1, 0, then here, uh, 24, 24 is, here will be 24, 1, 8, 24 plus 4, 50. So this 1FH is pointing to the R7. Okay, so this address 1FH will contain this value 0 for H. Okay, because we have selected register bank 3 using this two instruction, and then I'm writing move R7, 04. Okay, so this is how it is. Those register banks are actually used or selected by the 2 bits of your PSW register. Fine. Now here if you remember, I discussed that there are this register bank 1. Okay, I also told that this register bank, okay, this is the register bank 0, and this is the register bank 1, whose starting address is 0, 0 okay, and this end address was 07H for the register bank 0. And then this is, so 8 plus 8, 16, that is 1 of H. That's end address. Fine. Now here, mm, so this register bank 1 is also used as stack memory. Okay, now you know that stack memory is actually used for some special operation. Okay, that is to store the returning address when there is a call instruction. Okay, so we know that we'll study about this one. Suppose that I'm writing your main program, and somewhere let's say the instruction, and say let's say I'm writing here some instruction. Okay, like L call instruction, and then I'm writing L call. Let's say some address of subroutine, or in the name of subroutine. Okay, so let's say here this subroutine is the name of the routine, and there is next address. Okay, then we are writing here this subroutine is another program here. Okay, then I'm writing some instruction here. Then RET is the returning instruction. So see what is happening now when the microprocessor will execute this call instruction, then this instruction will cause the microprocessor to jump to the subroutine. Okay, so in that case, this will be skipped. this instruction will be skipped and the processor will start executing the first instruction of the subroutine. So after this last instruction RET, it is supposed to return back to the main program. Okay, so this is the main program. Here we have the main program. So it is supposed to return to the main program. Where it is supposed to return? Where it has skipped the instruction. Okay, so after executing this one, it is supposed to return here. Now the question is how it is going to remember whether it has to return to this instruction whose address, okay, we have, let's say, some address is there. So to this address, so this address, returning address, is actually stored in the experience. uh, and in our R microcontroller, that is stored in the link register. Okay, in R microcontroller this SP is not, SP register is there, but there is a link register. Okay, in that case this is stored. Now the here, when it is going to return to this returning address, the stack pointer register is going to store that returning address. So before it is going to jump to the subroutine, the returning address is saved to the stack pointer, and when it is the PC, you know that PC is always pointing to the next address. So the PC register will be loaded with the SP register value. Okay, here, and then it will return to this address. And also stack memory is also used to store data. Okay, stack memory is also used to store data using push and pop instruction. Push and pop instruction. So these two instructions are, this push is used, okay, this push is used to store register value, register value, okay, in the stack memory. And this pop instruction is used to retrieve, retrieve the data from stack memory into specified register. Specified register. So about this push pop instruction, we'll study this one. I mean, okay, let me explain this one right now. Let's finish this one. Okay, so what is happening? So let's say this is the register bank. Yeah. Okay, let's say this is 008. Sorry, it will start from 0 apex, then 09, 0A, 0B, 0C, 0D, 0E, and last address 0F. Like this. And these are the different locations of your register bank 1. And you know, this is, okay, let me draw this register bank 0. So this register bank 0, you know, this end address is 07H. Okay. And as I told you that when you start or switch on the microcontroller, okay, switch on, when you switch on your microcontroller, the SP register will contain 07H. Fine. Now, now suppose that you have written some instructions here. Let's say push R0, comma, 04H. Okay, then similarly let's have written here push R1, comma, 05H, push R2, comma, hash 06H. So what is going to happen? This register R0 will contain this 04. Now remember this address R0 is actually this register 08H. Okay, because I told you that when you switch on, the SP points to 07, and this register bank 1 is used for the push and pop instruction. So what is happening? This address 0FH will be loaded with this constant value 04. Similarly, this R1 register will be loaded with 05H, or you can say the next address 09H will be stored with this address 05H. Okay, like and so on. Similarly, R2 06H. Now you can say 0A will, address will be loaded with this 0H value and so on. Now see here, what is happening? Let's say this is register bank 1 and this is the address 0FH. So then we have written this first instruction push. Okay, R0 comma hash 04H. So at this time the SP was pointing to 07H. So what is the next address? The next address is 0FH. Okay, so in that address, uh, the 04H will be loaded. Okay, so this 04H will be stored. In the next time, if the 04H is already stored in the address 0FH, the next address is 098, sorry 09H, and then we have written here push. What we have written is push R1 comma R05H. Okay, and then we are at this moment. Okay, now since SP because your address 0 has been filled with 0 for so your SP will become SP plus 1 and it will point to address 0FH. And what is the next address? Next address is 09. So in that address this data 05 will be stored. Now even if I have not written here R0, R1, R2, any register no. So in that case also this would have worked. Okay. So one example is given here. So see here, this one. This first instruction is move R6 has 25H, move R1 has 20H, move R4 has 0H. And suppose that I've written here push 6. Now push 6 means we are moving, okay, one moment, mistake was done here. Okay, here this push instruction goes, push instruction uses register, sorry, indirect address. Indirect address. Okay, indirect address. So here we have to write like this. Push 6. Okay. Similarly push 2 and so on. So this is actually not correct. This one is not correct. This is not correct. We'll about push and pop will continue in the next class. Okay. So next class we'll discuss about this push and pop instruction. Thank you everyone.